Assalamu alaikum. The lecture on mechatronics. और हम डील करेंगे आज विद एक्चुएटर्स. सो जो हमारे पास मैकेट्रॉनिक सिस्टम है जिसकी बेसिक ब्लॉक डायग्राम हमने बोली थी ऐसे है. सो वी हैव सेंसर्स ऑन दिस साइड and we have actuators on this side and we have the system here, the control system. तो अभी तक हमने सेंसर्स का ठीक ठाक पार्ट देखा हुआ है जहाँ पे हम डिफरेंट एनवायरमेंटल वेरिएबल्स को देखते हैं. जैसे जो जो हम देख चुके हैं उनमें हमने देखा लाइट, we checked out proximity, we checked out distance, displacement, strain, force, pressure, temperature, etc. Then we were able to convert these environmental variables into the system variable that were mostly known as voltage V. But when the mechatronic system will work, it has to change and it has to get back to the thing called environment, because we have environment on the both sides. So we have environment on this side, we have environment on this side also. So on the actuator side, what we will have to do, we will have to do the reverse process. The reverse process is that this system variable now needs to be converted into the physical parameters, that is the environmental variables back. For example, the voltage needs to be converted into light back. It needs to be converted into displacement. It needs to be converted into force. It needs to be converted into pressure. In a way, we can say it needs to be converted into action. So those components, those devices that will help me to convert this system variable into the action into the environment are known as actuators. The most common form of actuators that we use are related to these things, that is displacement, force and pressure, that we have to apply in mechatronic systems. And about this light and heat, we may have the actuations for heat and light also, but that is not of that order as the usage is for displacement. So as we were sensing the displacement, so we had two types of displacement. One was linear displacement and the second was angular displacement. Same way we will have the actuation. So in terms of displacement, we will have the linear actuation and we will have the angular actuation. So for linear actuation as well as angular actuation, the first thing is how we need to actuate on the displacement side. The second is what is the amount of force or torque or pressure that this actuating unit has to apply. So the actuators will then be classified according to the volume of force, torque. So the volume of force, torque and pressure to be applied to the system. to our load. In fact, we can say to our load. So on that basis, we can have linear actuation with those actuators that can provide a low level of force, torque, or pressure, and the second class of actuators that can provide a very high class of force, torque, and pressure to the systems. So we can classify them as electrical actuation systems, where we will have both linear and angular actuation. For angular, we will have rotational. And then we have mechanical actuation systems, wherein we have two main types. One is the pneumatic, the second one is hydraulic. And for pneumatic and hydraulic, for both of them, we have again the linear one and the angular one. The linear one, the angular one. So in electrical part, the linear actuators are of two types. One is primary, second one is secondary. There's the primary linear actuator and the secondary linear actuator. So what do you mean by primary linear actuator? Wherein we have an actuator, we supply this with electrical energy, and it simply has a linear motion. And the best example for this is solenoid. We call it as a solenoid. So we provide it with AC or DC voltage, and there will be a linear displacement. So it will be called as a linear, primary linear actuator, electrical basis, so it's known as solenoid. Secondary is that at the output we have a linear actuation. At the input we provide it with the voltage, the AC or DC current and voltage, but it is not direct linear output. At the mid there may be an angular output or rotatory output. That means it's actually converting the voltage to rotational motion, then converting that rotational motion to linear displacement. The examples for this secondary linear actuation can be motorized, corkscrew mechanism, or motorized rack pinion mechanism. And about the electrical one, rotational, that means the angular or rotational actuators. In electrical we have motors. So motors are classified on various ways on the basis of type of AC voltage that we give. So we can have AC motors, we can have DC motors. Then on the basis of type of operation, in AC we can have the AC synchro motors, and we can have and induction motors. So then in induction motors we can have the single phase or the multi-phase motors. And then in DC we have permanent magnet motors. In permanent magnet DC motors we have brushed permanent magnet DC motors and brushless permanent magnet DC motors. Then we have non-permanent magnet motors. These are again DC motors. Then some variations of the motors, and we have stepper motors, and servo motors. In servos, we have digital servos and analog servos. And then in stepper motors, we have permanent magnet stepper, we have self reluctance stepper, and hybrid stepper. So these are the types of motors that have different properties and different domains of work, and they can be used for different applications. All of them have different design considerations, and they are used for different things. And all of them are used for the actuation, whether that be rotatory actuation, angular actuation, or linear actuation. For the linear actuation part, they are used as the mid element, and it is their output that is then the rotatory output is converted into the linear output, and then that can be used as linear actuators. The mechanical mechanisms are normally used. You can have the pulley mechanism also that may be used to convert the rotatory motion into the linear motion. So let us start with the linear actuators. So linear actuators are normally DC operated. Can be AC operated too, but with some minor adjustments. So What is there in linear actuator? You simply have a coil. So you have a slot, and along that slot you have a coil. So inside this slot is housed a ferromagnetic material, normally called in solenoids as armature. You may get confused that armature is normally used for the wire, the insulated wire that we use. But here in solenoids, armature is the device that actually plunges in and out, then that is actually actuated. So what happens whenever you provide the current AC or DC, this core gets magnetized, and there is a flux that gets induced into this armature, and because of the flux induced in the armature, this plunger simply plunges out, it goes into one direction. So it gets a linear actuation, it gets a force in this direction, and it gets in and out. So if we simply give the voltage here, this armature will be thrown out. So what you do, you use a mechanical system to constrain its motion, and in order to bring it back you normally use a spring. So you put a spring on this side. So whenever you put a current or voltage, a designated voltage, the voltage that we have to provide depends on the force that this plunger or this actuator has to provide to the spring. It depends on the spring constant K, and it depends on the length that it has to move, the delta L. It depends on the number of turns of the coil that you have wound on it. It depends on the area of the cross section of the conductor that you have wound there. It depends on all of them. So it actually depends on the application, what the force that you have to provide when you have to actuate, when you have to linearly get something in or out. So this spring, once you release the voltage, this spring will get the plunger back into its position. So if you have to show the solenoid, you can show it like this. This is the casing, then you have the slot, then you have the coil. You can show the coil like this, coming on this side, going on this side, and then you have this armature. Now depending on the type of this armature, you can have four different types of solenoids. One is disc type. There we don't have a plunger, we have a disc. So if this is, so I will now show it at a larger scale like this. So you have a disc here. The armature in the form of a disc. What is it used for? It is used for those particular applications where you need very small displacements, but you need a good amount of force. Then you have the second one, that is plunger armature, where you have plunger that plunges in and out. It's the plunger one. This was disc type. Then the third one, that is conical plunger. So the difference between normal plunger and conical plunger is that the conical plunger is conical in shape on this side. And at last we have ball plunger. So whenever you provide it with the voltage, this ball is displaced up and down. When you provide it with the voltage, this disc is displaced up and down. When you provide this with the voltage, this plunger is displaced up and down. So all of them are linear actuators. So where are they used? Some applications, like you have automatic windows locking mechanism in your cars. So for example, you have a remote control operation of the windows of your car or the doors of your car. You press the button, unlock, and you check out that there is a click, a sound in the door, and that's actually the sound of this plunger that comes out and simply opens the lock inside the door. The application of this ball type is in mechanical actuation systems. This is actually used as a primary actuator or as a switch in our hydraulic and pneumatic actuation systems. Okay, so now you have two types of linear actuators. One is simply on off, that is bi state. You will either have the plunger on this side or on this side. And the second one is continuous. Continuous means that whose displacement can be controlled, where L can be controlled, the total displacement that you have to take. And the primary linear actuators are normally off on off type because they have the plunger mechanism. It simply is that the plunger will be on one side or on the other side, whereas the linear actuators the analog linear actuator or the continuous linear actuators are normally made out or secondary, that they are made out of those rotational things. So now we have to think about the controls. So let us put the linear actuator like this using its symbol. So how to control it? So obviously it will have a spring, then it will shoot up and down. So it will have two phases. One will be when this coil is energized. So when you energize this coil and up to the particular time after which you energize this coil, the plunger will be at position B. So it will come to this position. It will be thrown out. And when it is de-energized, it will come back to its original position, say A, using the spring. So depending on the things that I mentioned before, so it will take some current I and will have working voltage V. So in order to get this solenoid operated by a controller, so on this side we have a controller. That controller will be simply providing us the output in the form of 0 or 1. That is logical side. Or if we take the voltage variable into consideration, it may be according to the maximum type of processors. It can be 5 volts or 0 volts. So means If you provide it with this logic one, that is 5 volts, it should be able to go up, and if you provide it with the 0 volt, it should come down. But that's not possible because all the processors that we use, the pins can provide you 5 volts at logic 1 and 0 volt at logic 0. But the maximum current that they can source here or sink here is in milliamperes. That too, not more than 40 milliampere. But the solenoids, according to different loads and plungings that they can do, they will need currents of the order of from hundreds of milliamperes to tens of amperes. So obviously the solenoids can't be controlled directly by the logic or the voltage provided by your controller. So what needs to be done? You need a driver. So you need a driver. Driver means a subsystem, an electrical system that can drive your solenoid. That means that will provide it with the requisite amount of current and a requisite voltage so that it will plunge in and out, providing the force or pressure that it has been designed for. So the best driver or the electrical actuator, a second type of electrical actuator that we can in fact say, is called as relay. We can use a relay here. What is a relay? A relay is simply a signal operated switch. So we already know what is a switch. A switch is a device, a mechanical device that simply lets 2 points A and B to connect to get open or a short. So the switches are of two types. One is manual switch that we use. So for example, bed switch, you have push button, and then you have big switch like the one called a changeover that you use to change the power for your whole system. For example, for the home power supply, the power supply for the whole house, if it is to be changed, then we change over. So what do you mean by can't we use a simple bed switch to change over to get the supply for the whole house on and off? Can't we use a push button to get the AC bulb on and off? That is, can't it take the position of bed switch? The answer is no, because these mechanical devices, that the switch, they also are made mechanically and they are having some considerations. What are those considerations? Again, the voltage that they can switch and the currents that they will switch. So it all depends on their size. As their size increases, they will be able to switch higher voltage and higher currents. But coming with the size, you will obviously require more power to get them on and off. And it also depends on the size, the time of contact. For example, for a bed switch, the time of contact between A and B, if it is less, It's not a problem. But for a changeover, the time of contact between A and B should be very fast, so that there is very less time of snap between A and B. What happens when you have very less time of snap? You avoid things like sparking. And if there is spark in the material that constitutes it A and B will get deteriorated over time. That means the switch will fail after some time. So the snap needs to be very fast. So the mechanisms, the spring mechanism and other mechanisms are already taken care of that help the snap to take its action very fast when you have higher voltage and higher currents. For push buttons and bed switches, it's not necessary that the snap should be fast. Okay, now if you have this was these were the mechanically operated switch that you are operating this switch using your hand or finger. Now if you take a switch and operate it through a signal, that means the voltage itself, the current signal or the voltage signal itself is operating the switch, the main switch, then it will be called as a relay. So the common form of relays that we use are called electromechanical relays. Simply, what is an electromechanical relay? It is the switch that is being operated by something that is electromechanical. That you give a signal, with respect to that signal, a mechanical output is generated. That mechanical output makes the switch on or off. We also call them as electromagnetic relays. What do you mean by electromagnetic relays? A special type of relays which will operate the switch, will get the switch on or off. What will get the switch on and off? An electromagnet that is operated by a signal. So the electromagnetic relays. We also have optical relays. We have gas operated relays. We have solid state relays, etc. But the most common form of relays that we use is this electromechanical or electromagnetic relay, because of the lower cost and because of ease of interface. We can interface them easily. Okay, so what is the structure of this electromagnetic relay? It is simply, we have an electromagnet. This is some ferromagnetic material. There's a coil wound around this ferromagnetic material, so that whenever I provide it with a voltage V and takes current I, this particular material gets magnetized and it becomes a magnet, so that there is north and south pole now. Then we have a strip. This strip is such that it will be attracted towards this electromagnet whenever we energize this, and it is kept off when we de-energize this. So in order to keep it off, we need a spring. We have a spring that is normally connected to the housing of this relay. So whenever I give voltage to this electromagnet, this ferromagnetic material will simply be attracted towards it, and when we release the signal, when we release the connection here, it will come back. So what is done normally? It is connected to a switch. A simple contact is connected to this. It is again connected from this side to the housing. Then we have two more contacts that are kept either side of this contact. So normally when we don't energize this relay, this spring will help this ferromantic material to go up. So in a way, this contact C gets connected to this contact A because of the spring, and this contact A is normally known as NC, that is normally connected, because when it is in normal state, the normal state for the relay is de-energized state, when you don't haven't energized it, when you haven't given the voltage here to the relay coil. So it will be the spring that will be putting this point C in contact with point A. So you will have a connection between NC and C, and at that time this second connector is open, it's not connected to anything, so you call it as NO, that is normally open. So in normal case, when you put this relay in your hand, you haven't connected this, so you will keep one thing in mind, that at that time this NC, that is normally connected connection, will be connected with the common, C will be known as common now. And then when we provide the requisite amount of voltage and current to the electromagnet, what will happen, this electromagnet will get this is also called a plunger here, like we see in our linear actuator. The difference between the linear actuator and this relay mechanism lies only in the amount of voltage and current that needs to be given. We need very low amount of currents and voltage to be given here in order to get this plunger from this position to this position, because here we only need to get the contacts between NC and C and NO and C, and we don't have to do any mechanical work where we need extra force and pressure. So when we give the requisite amount of voltage here, this will be attracted, so the connection between C and NC will break, and the connection between NO and C will make. So you will have a make break arrangement. So it is because of this make break arrangement you will be able to switch it on. So it's as good as you have switched the push button on by your finger, and this we can relate that you have provided it with a signal. Let us suppose it operates at 5 volts, so you are giving you the 5 volts to this, these two terminals normally designated as C1 C2, that means coil 1 and coil 2. So when you provide 5 volt to this gets energized and your connections C and NO get connected, but at the same time the connections C and NC get disconnected. So this particular type of relay is called as SPDT relay, because we have a single pole. This is called a pole that goes up or down, and it has two connections to get connected to, that means 1 and 2. So it has two throws, this is throw 1, this is throw 2. So it will be called as single pole dual throw. The pole has two throws on this side and on this side. SPDT, single pole dual throw relay. And this single pole dual throw relay will act as an electrical actuation system that will actuate a bigger thing. And you will see in future then that bigger thing, that is a bigger thing at this point of time, that means linear actuator will be a small thing for some other big thing like your hydraulic or your pneumatic actuators, so that will be then actuating those things. So it is a ladder mechanism. So if we have to control some very big thing, you do it in a staggered manner. You first use a small driver to drive this, it then drives this, it then drives the big thing. So you can't switch it directly. This big thing, if you need to switch, you can't switch it directly, so you need to the extra amount of power then. So what you do, you simply do it in steps. You first use a small driver to start a relay. This driver we haven't gone through, we will go through it in some time. Then this driver will start the relay will start the solenoid, and then the solenoid will start the hydraulic or pneumatic actuation system. So it's a one, two, three, four, four-step process. So you have to do a single thing. That is what is to be done at last. What you have to do. First, you have to lift something. But in order to lift that, in order to provide it with the actuation, the signal that you will provide here will be simply done by the processor, and it will provide you very low voltage and low currents of the order of 20 milliamperes. But using this low voltage and low current, you will be able to lift very high, very uh, loady, very high loads by a staggered mechanism. So now we have already checked out the solenoid. Now we checked out the relay, and now we will have to see the driver that will drive this relay, because again there is a problem. We have reached to a lower voltage, 5 volts, that will operate this relay, but again your microcontroller can't provide the current that will get this relay on, because the relay will again take currents of the order of 100 milliamperes. So in order to drive this relay, you need one more driver. Like I said, that you need one more step prior to this, that is you need one more driver, and that those drivers are normally solid state drivers. So they are made up of solid state devices. So we can use transistors, we can use MOSFETs, we can use SCRs, we can use thyristors, we can use IGBTs. There are many devices. The new devices are coming every now and then, so you can use any of them. Okay, now let us have a case study wherein actually we have to control a pneumatic valve that is controlling some machine that is generating some pressure of the order of 20 kilopascals, and this pneumatic valve is to be controlled by a solenoid, the ball type solenoid, because the ball type solenoid will directly act as a valve for this pneumatic system. Then that ball type solenoid, let us suppose, is voltage operated, and it takes 12 24 volts, and the current that it takes is 5 ampere. And then we need to operate this ball type solenoid by a relay that we checked out before some time, and this relay operates at 5 volts, but it takes 100 milliampere. And now we will look at a driver that will require at the input side same 5 volt but very less current of the order of tens of milliamperes, and at last, and will provide us with this thing, and at last we will have a processor that will be processing the thing. So here I said this driver can be your BJT, that is bipolar junction transistor. It can be your MOSFET, metal oxide field effect transistor. It can be IGFET, insulated gate field effect transistor. It can be IGBT, insulated gate bipolar junction transistor. It can be thyristor, SCR. It can be track. So there are many devices that can be used. So let us take BJT, because you may have gone through this BJT in your lower semesters. So for BJT, what now we will do, we will simply have the processor that will be providing a pin. This pin will provide us with 5 volt or 0 volt, that means logic 1 or 0. Then it will simply go to the transistor. The base of the transistor will be put connected to the pin. The emitter of the transistor will be connected to the ground, and on the collector leg we will connect our coil of the relay, that is the C1 and C2, and on other side it will be connected to the relay voltage, that is the 5 volts. So then you have this relay. On the other side of the relay you will have three contacts. One is common, the second one is normally open, the third one is normally connected. Now we have to put the solenoid, the ball type solenoid. So for ball type solenoid we will have, let's put it like this. So it is a 24-volt 105 ampere solenoid. So what we will do, we will use a power supply that is designated for this, that's plus 24 volts. Then the second point will go to the common and NO will go to ground. Then this plunger or this ball will be used to control the, let us suppose, your pneumatic valve. So it is a staggered process. Now what will happen here, you already know that this transistor here needs to be connected as a switch. So you will require the biasing mechanism so that it is used as a switch. Switch means it must simply go from saturation to actuation, sorry, saturation to cutoff and back. So when you give 0 volt to the base, there won't be any current, you won't be providing the 0.7 volt PN, the new voltage. So you won't be getting the transistor on, so it will be cut off. When it is cut off on this side, so this relay will get 5 volt on one side to the coil, but on the other side it is cut off, so relay won't be on, relay will be de-energized. So when relay is de-energized, this C will be connected to NC, not NO. So this solenoid valve will get plus 24 volt on side, but on other side it is open, so it won't operate. So when this won't operate, the pneumatic valve won't operate, or pneumatic valve will be in state 1, S1. Then when you give it 5 volt, that is logic 1, the transistor will operate. The transistor will be given an ample amount of base current, that is up to 20 milliampere, and it will now have 5 volts, so it will provide it with the 0.7 volt that it needs to get saturated. So when this transistor gets saturated, it simply is equivalent to the C gets connected to E. Now to the relay you have got 5 volts on one side and ground on other side, so relay will get operated. When relay gets operated, the common will get connected to NO. It will break the CNC bond and it will come to CNO bond, and now this solenoid will get plus 24 volt on one side and ground on other side. The solenoid will operate and this ball will be plunged into the pneumatic valve, and pneumatic will move to state S2. That is what we were going to have. So you have now seen there was a 4-stage process to get to this point where we have to get a pneumatic valve that should work for some really big thing. So we had to go first through the solid state driver, then we had to move to the relay, and after that to the solenoid, and at last we moved to the pneumatic valve. It is how it is done, the controls are done, and still we are simply checking out the on off control. That means the pneumatic valve here is going only from state 1 to state 2. So are going the other things. So solenoid valve is also going from state 1 to state 2, the relay is also going from NC to NO, and the transistor is also going from saturation to cutoff. So all of them are working in two-state manner, so there is nothing continuous. So you may have the things where you will have to go continuous also, so that will be taking in some other lecture.